Hello everyone, today we're doing problem 6.10 and this problem gives us a structure of methoxycyclohexane in its axial and equatorial position. So obviously axial being the starting material, equatorial being the products on the right. And we're given a KEQ, so an equilibrium constant of 2.7. So just like in problem 6.8, we know that a positive equilibrium constant means that the products are going to be favored. Why? Because it's larger than 1. Having an equilibrium constant larger than 1 tells us that there's going to be more products than starting material and reactants. So we know that the answer to A, we know that because of our equilibrium constant being larger than 1, we know that the product being the equatorial position is going to be in a larger abundance at equilibrium than the starting material. Not only that, because we know that we're going to have more products than starting material, we know that this reaction must be endergonic, meaning that our product has lower energy, therefore more stable, and therefore negative delta H, not delta G value than our starting material. Conversely, because we know the equilibrium constant is larger, we know that the starting material has higher energy and is in low abundance than the product. So because we know the product is lower energy, it's more stable than the starting material, therefore a higher percentage of the population of these molecules will exist as this more stable form. And because we're going from high energy to low energy, we're losing energy from this reaction and we're giving it off to the surrounding. So because of that, we know that delta G must be negative because we're losing energy. It's an endergonic reaction. And using this table, we see that with the equilibrium constant in the order of magnitude of 10 to 1, we know that delta G, obviously, because we have a positive KEQ, delta G is going to be negative. And remember, if KEQ is greater than 1, delta G is negative. KEQ less than 1, delta G is positive for those trends that we talked about in this and the previous question. So using these tables, order of magnitude of KEQ is 10 to the 1. So we know that our delta G value is not only going to be negative, but it's going to be anywhere between 0 to 6 kilojoules per mole.